have a system of equation problem is they try to throw all of the numbers into the equation to create one big, huge equation. So please don't be tempted to do that. We want to be able to find two equations. So somewhere in the problem, there's going to be two equations, and most of the times the numbers don't overlap. So like if you used 300,000 for one equation, you're not going to use 300,000 for another equation. Not always that's the case, but most of the time that's going to be the case. So they're giving us a little bit of help with this problem because they're telling us what are the two equations we need to write. So the first part says that we want to write the cost function of producing X pairs of running shoes. So remember, when we set up application problems, take a minute to write what the variables represent. So X stands for the number of pairs of running shoes. I'm just going to say of shoes. Okay, so X stands for the number of pair of shoes. So now they're asking us to write this cost function. So again, it's a function, so that means we need to write it in function notation. So the name of the function is C. In function notation, we would say C of X with the little parentheses. So let's write what that stands for. So that stands for the cost of producing the shoes. Okay, so now we wrote down what our variables represent. So now let's write the cost as an equation. So they say, let's highlight this, there's a fixed cost of $300,000, and additionally, it costs $30 to produce each pair of shoes. So those are the numbers that are gonna go with our cost equation, because those are the numbers that have to do with cost. So our cost equation is going to be C of X is equal to 300,000, so it costs $300,000 plus $30, and then for each pair of shoes, so in that sentence, the word each implies that we're going to multiply, so $30 times the number of pairs of shoes. The number of pairs of shoes was X, so 30X. Okay, so that's our equation for a cost function. Now we have to write us another equation for the revenue function. Again, they're giving us a little bit of help, so they're telling us what the two equations are going to be. So our revenue equation is going to come from, they are sold at $40 per pair. So revenue is basically how much money they're bringing in when they sell the shoes. So the revenue function, so R of X is the name of the revenue function, and that's going to stand for the revenue. I'm going to say the revenue from selling the shoes. Okay. All right. So the equation for the revenue, since they're selling them at $80 per shoe, per pair, $80 per pair, the revenue is going to be $80 times X times the number of pairs. So we've got two equations here. And again, it's a system of equation, meaning we have two equations that apply. Now, this one here, we want to determine the break-even point. So the break-even point is technically where the cost and the revenue are the same value. So break-even point means that the cost is the same thing as the revenue. So let me we'll write this in terms of the X's and Y's. If the cost and the revenue are exactly the same, basically they're both going to be, let's call it Y. So that means if I want them to both be the same, Y is going to be the cost of producing, Y is going to be 300,000 plus 30X. So let's let Y stand for the cost of producing the shoes. Which also means that the revenue from producing the shoes should be the same amount, so it should also be Y. So Y is equal to 80X. So this is where now it looks more like the system equation that we were looking at. So those two values have to be the same, so we'll call those two values Y, and then we'll solve that system. So the next thing is to go ahead and solve the system. So when we solve this system, it's kind of, this one's like not too bad to solve because we're basically using the substitution method. We're basically substituting, say we substitute 80X in for Y into the first equation. So let's pick purple. So this would look like 80x equals 300,000. So they have to be the same. So we want to know, when are those the same? That's where we break even. So to solve this, we'll go ahead and subtract. So we'll subtract 30x from both sides. So we'll get 50x is equal to 300,000. Then we'll take x, we'll divide it by 50. So we take 300,000, we divide it by 50. So when we do that, we'll get x is equal to, it'll be 6 with 3 zeros, so 6,000. So x is 6,000. So now it says, describe what this means. So we need to actually describe what that x is 6,000, what that number is that we have found. Oh, by the way, before we do that, let's actually figure out what y is, because notice that when we solved a system of equations, we wanted to find x, but we also want to know what y is. So let's kind of do that back substituting. So if we back substitute into that equation, y equals 80x. So y is going to be 80 times 6,000. Oops, too many zeros. So y is 48 with 4 zeros. So 480,000. All right, so now we got to describe in words what does that x and the y mean? So the 6,000 and the 480,000. Now we've already seen x is the pair of shoes. Now the y was basically the revenue and the cost being the same, right? Because the y stood for both the revenue and the cost. We wanted to know when they were the same. So the y is going to be when the revenue and the cost are the same. And so it's going to be the same when those values are equal to 480,000. So let's write this out in words. So we would say the break-even point that's what the question asked. So we're going to answer it in terms of the words of the problem is when the revenue is the same as the cost, and this will happen when they produce 6,000 pairs of shoes and we'll have to say what that 480,000 is. So the revenue and cost will be 480,000. Okay, so break-even point is when the revenue is equal to the cost. Again, if we have two different equations, we can set those up. Let me actually show you what this looks like in, let me get Desmos going. Let me show you what this looks like in a graph. So here's in Desmos, I graphed the two equations. So the first equation I graphed was the 300,000 plus 30x. That was the cost function. The second equation was the revenue function. So 80x, and we wanted to find out when those are the same. So if you look at the graph, I set up the graph so that you can see. So we had to change the scale. So if you were looking at this, notice that the scale that I used basically was a little bit before 0 up to like about 10,000 on the x-axis. The y-axis went from a little bit before 0. I put in some negative numbers. Actually, you can see what I put in here. So maybe negative 10,000 up to maybe 700,000. It kind of changed it a little bit. So just make sure that you got a graph that's going to include all of these big numbers. You might have to change the scale to do those. But if you look at this, we can see the break-even point is the point where those intersect. Now, the other thing that's kind of interesting about graphs, when we talk about break-even point, it's interesting to see on these graphs is because the red function is the red one was the one that represented the cost. So at the section that's going to be before the break-even point, notice that the cost is, the red line is higher than the blue line. So the costs are more than the revenue. So that's basically the company's losing money in that section. So when they sell basically less than 6,000 shoes, the revenue is going to be lower than the cost. So they're going to be losing money. So they break even, so basically make zero profit at 6,000. And then after 6,000, notice that the blue line is on top of or higher than the red line. So after 6,000, that's when they start to make a profit. So before 6,000 pairs of shoes, they are losing money. After 6,000 pairs of shoes, now they're making a profit. So if you take a business class, they might call those economies of scale. So once they sell a certain amount of shoes, now they're making more and more money for each pair of shoes that they sell. Okay, so that is break even. Again, we can look at a graph. All right, let me do another example of a word problem. And this is one that we did, I did an example of this before, so I'm just going to we're just adding on to that example. That was with those mixture problems. So these are often problems that you'll see with a system of equations. So we've got a chemist that's working on a flu vaccine, and he needs to make a 10% sodium iodine solution. He's going to mix a 10% sodium iodine solution with a 60% sodium iodine solution to obtain a 50 milliliters of a 30% sodium iodine solution. And we want to know how many milliliters of a 10% solution and how many milliliters of a 60% solution should be mixed. Okay, so that's our question. How many of each should be mixed? So let's start out by setting up variables to answer that question. So let's let X stand for the milliliters, I'm going to abbreviate it MO, of a 10% solution. And let's let Y be the other variable, and that's going to stand for the milliliters, or the amount of the 60% solution. Okay, so again, set your variables up. Please write those down. It's going to help a lot if you write down what your variables stand for. And again, we've set them up to answer the question. All right, so if you remember, let me draw that picture again. So what this is, again, basically is they're going to take this, like a little, I don't know, some little gallon jug or little container, maybe a vial, I don't know. And basically, this is the 10% solution. So we don't know how much of the 10% solution. So I'm going to just write the variable X here. That X stands for the total amount of liquid that's in that 10% solution. So the total amount of liquid is going to be X milliliters, because that's how much we're going to pour out. Now, of that X milliliters, remember when I drew this, part of that is going to be the pure, in this case, sodium iodine. So this is basically the part that's pure sodium. I'm going to just abbreviate sodium iodine. Okay, so that's the amount. That's that pure sodium iodine. Now, in our problem, that amount is going to be 10% times the variable X. So it's going to be 0.1 X. So again, if you think about it, it's going to be the percent times the amount. Okay, so that's going to give us how much sodium iodine is in that vial. Okay, so then we're going to have another vial, and that other vial is going to have, we don't know how much, but we set up the variable Y to stand for the total amount of liquid that's in that one. And then again, that one is going to have a 60% solution, so more of that is going to be the pure sodium iodine. So that's, we would call that, if we want to know how much it is, we would take 60% of that. So 60% of Y is going to be 0.6 Y. Okay, and again, these two guys represent the amount of pure sodium iodine. Now, what we're going to do is we're going to take the whole liquid, we're going to pour it together into this bigger container. And in this bigger container, they tell us in the problem that we want to have 50 milliliters. So, and this is going to be a 30% solution. So it says we want to have 50 milliliters of a 30% solution. So again, the amount of iodine in that solution is going to be 0.3. So 30% times 50. So it's the percent times the amount of liquid that we have. So it's 30%, so it's 30% of 50. Okay. So again, this is the amount of that pure sodium iodine. All right. So what's going to happen here is we are basically going to have two equations, because it's a system of equations. So we're looking for two equations. The first equation, let me go over here. The first equation is going to come from the total values. So notice that if I have x in one of the containers plus y in the other container, when I pour those together, I should get the total that I have, which they told us we needed 50. So again, you're going to have one equation that's going to come from the total. And then you're going to have another equation that's going to come from those highlighted parts, the sodium iodine, that's the amount of sodium iodine. So it's going to look similar, but it's just going to be 0.1x, so these are all the percents, plus 0.6y is equal to, and don't forget the percent for this one, 0.3 times 50. Okay, so you got a total equation, and then you've got one that's like the percent equation. And this percent equation basically represents the sodium iodine. Okay, so the amount of the pure sodium iodine that's in there. Okay, those end up being, that's your system of equations that you need to solve. So now we can go ahead and solve this system. And actually, I've got some space over here, so we'll just solve it right here. So we can go ahead and solve this system. So to solve this system, I'd probably use substitution to solve this one, because you see in that first equation, it's not too hard to get them by themselves. So again, we're going to use a substitution method. So the first step was to solve for one of the variables. So let's just solve for y for this one. So if I take x plus y equals 50 and solve it for y, I'm basically going to subtract x from both sides. So I'll get y is 50 minus x. And again, I subtracted x from both sides. Okay, and then remember the second step was to substitute. And it has to go into the other equation. So the other equation, okay, let me write down the other equation, was 0.1x plus 0.6y is equal to 0.3 times 50. So we're going to substitute. So that means we're going to take this expression and put it in for y. So we'll have 0.1x plus 0.6, but instead of y, I'm going to write 50 minus y. Oh yeah, 50 minus x. And go ahead and you can multiply out 0.3 times 50, and that's going to be 15. Okay. Now remember, when we solve these equations, don't start adding or subtracting to both sides until you simplify them. So we need to first distribute and get rid of any parentheses and combine like terms. So we'll have 0.1x plus, if you take 0.6 times 50, you're going to get 30. And then minus 0.6x is equal to 15. All right, and again, don't start adding or subtracting to both sides. We can combine these like terms. So we'll have 30 minus 0.5x. So 0.1 plus or minus 0.6 is going to give me negative 0.5. So that equals 15. Now we can start to add or subtract to both sides. So we're going to subtract 30. So we'll get negative 0.5x is equal to negative 15. Then you'll divide both sides by negative 0.5. So you'll get x is equal to, so it's a negative, so x is going to be equal to 30. All right, and then we're not done because remember we have to find both equations. Oh, by the way, this was step 3 to solve. So step 4, let me write it up here. Oh yeah, we don't need the word step, just 4. So step 4 was to back substitute. Okay, so we're going to take that x equals 30 and substitute it back in. So pick any of the equations. So let's pick the easy one, x plus y equals 50. So we're going to take 30 for x, plug it in. So we'll get 30 plus y is equal to 50. So we'll subtract 30 from both sides. So we'll get y is equal to 20. Okay. All right, so now don't forget to answer the question. So let's go back over here and we'll answer this question. So we got x is 30, y is 20. So we're going to say we should mix 30 milliliters of the 10% solution and 20 milliliters of the 60% solution. Okay. All right, so let me go back to the equations that we came up with, because I want you to recognize that we're going to actually start to come up with equations that are similar in form to even this mixture problem, but it won't look like a mixture problem. Notice that the first equation that we had, actually let me highlight it in a different color. The first equation that we had was basically the total. Let's highlight this. Was the total. So the first equation came from the total amount. And the second equation, again, came from the percents. So in this case, we added up the percent times the amount. So if you think about that formula, I wrote it in purple, we basically had the percent times the amount plus the percent times the amount is going to equal the total percent times the amount. Okay, so you're going to have this other equation that's going to be like the percent equation, where we're basically taking the percent times each amount. So, again, hopefully you'll also recognize that, notice we've got an x and an x, and we've got a y and a y, and also so you don't forget it, because this 51, people tend to forget that one. And then we've got a 50 and a 50. Okay, so we're basically adding the total amounts in one equation and then applying the percents to all of those, each of those amounts to get up to the percent equation. Okay, they're always going to be set up exactly like this. So if you practice this enough times, you'll start to recognize, oh yeah, it's basically the same setup every time. So it looks a little hard the first time you see it, but after you do a few of these, the process is going to be the same exact process each time. Okay, and again, we'll have a total and a percent. All right, so that one was probably the more challenging one of all of them. But again, we've started out, I've drawn that picture for you before, so hopefully that wasn't too new. We only added that x plus y equals 50. That was kind of the new part. All right, so let's do the last problem. And this one's not going to be too bad. This one, you've got a rich uncle. He dies and leaves you an inheritance of $30,000. That'd be pretty cool. You decide that you want to keep that money, but you want to invest it in a bond fund that's going to earn 3% per year, and you'll invest the rest of the money in a stock fund that earns 8% per year. Now, your goal is to have $1,800 at the end of the first year to pay towards your tuition at school. All right, and then the question says, oops, let me get that back. Okay, the question says, how much should you invest at each rate? Okay, so now the first step whenever you have any word problem is to read through it, highlight the question, and then define what your variables are. the variables should answer the question. So let's let, I don't know, we'll let x equal the amount that you're going to invest at 3%. And let's let y equal this amount that you're going to invest at 8%. Let's add in the bond fund. At 8% in the stocks. Okay. All right. So let's go see what other information they gave us. And again, our goal is to make two different equations. So do not be tempted to start throwing these into one equation. So don't try to mush all the numbers into one equation. Okay, so the first equation is going to come from, again, it's going to be a total. So it's going to come from this $30,000. So that equation is basically going to be, if I take the amounts and add them together, that should equal $30,000. So that would be x plus y is equal to $30,000. Okay, so again, we've got this is basically the total equation. That's the total amount of money that we have. Now, notice that next we're going to actually have an equation that has to do with the percents. So you're going to put part of the money at 3% and part of the money at 8%. So the part that goes at 3% is the x. So you're basically going to have 0.03 times x. So that's how much money you're going to earn in the bond fund. So you'll take 3% times the amount. So again, it's kind of similar. We're doing percent times the amount. Plus, then the money that we're going to earn in the stock fund is going to be the percent times the amount. So 0.08 times the amount y. Now this one is not going to equal, oh, I forgot a zero up here. This one is not going to equal $30,000 again. It's going to equal the total earnings. So notice that we want to have $1,800 at the end of the first year. So that's going to give us, that's where the percents come there into play. So that's the percents is how we're going to earn that $1,800. So when we add those earnings up, it should add up to $1,800. So this is basically kind of like your percent equation. So we needed to figure out how did we come up with the total number, and then how do we come up with the percent, or we can call this the earnings equation too. Okay, but again, now we've got a system of equations and we need to solve it. So you can solve it using any of the methods. Let's go ahead and solve this one using substitution again, because it's kind of easy to get one of those x's or y's by itself. So let's use the substitution method. I'm going to scooch it over here. So again, the first method for substitution was to solve for one of the variables. So I don't know. Let's solve for y again. So if I've got that equation, x plus y is equal to 30,000. If I want to solve for y, I'm going to subtract x from both sides. So y is going to be 30,000 minus x. And the second step was to substitute. Okay, so we're going to substitute it into the other equation. So the other equation was 0.03x plus 0.08y equals 1,800. So we're going to take this guy here and we're going to substitute it in for y. So we'll have 0.03x plus 0.08. Y is 30,000 minus x, and that equals 1,800. Okay, it looks like a long equation to solve, but it's not too bad. So remember, we're just going to simplify both sides before we do anything. So 0.03x plus, now if I take 0.08 times 30,000, so 0.08 times 30,000 is going to give me 2,400 minus 0.08x. And again, all that equals 1,800. And again, don't be tempted to start adding or subtracting to both sides until everything is simplified. So it's not simplified yet because we've got two like terms. We've got two x's that we can combine. So let's combine those two x's. So if we take 0.03 minus 0.08, we'll get minus 0.05. Okay. Now we can start adding or subtracting to both sides. So everything's been simplified. All our like terms are combined. So now let's start undoing the stuff that's around x. So we'll have negative 0.05x is equal to, and then 1800 minus 600, 8 minus 2400 is going to give you negative 600. Okay, and then the last thing we need to do is to undo that negative 0.5, so we're going to divide by negative 0.5. I'll write this up here. So when we divide by negative 0.05, we'll get x is equal to, it should be 12,000. All right, we're not done yet because the next step is to back substitute. So again, pick any equation, but I'm going to pick the easier one. X plus y is equal to 30,000. So x plus y is 30,000. So that means that you're going to substitute 12,000 in for x plus y is equal to 30,000. So then you're just going to solve this by subtracting 12,000 from both sides. Sorry about the husband yelling. All right, so y is going to be equal to, that'll be 18,000. All right, so we need to answer the question. So the question said, how much should you invest at each rate? So don't forget to go and answer the question. So we found, let's see, x was 12,000, y was 18,000. So you need to say that you want to invest $12,000 at 3%. And then you're going to invest $18,000 at the 8% rate. Okay. Okay, so those were the 3 problems that I wanted to go over with you in class. So the other 2 problems are going to be practice problems. So I'm going to leave those for you guys to do to practice. I will write the answers so that if you wanted to find the answers, you'll find them in OneNote. But I do want you guys to take some time and practice those on your own. And then when you're ready, you can go look up what the answers are in OneNote. But those 3 problems, hopefully that will get you through the rest of the way to do your homework. And then again, look for an email from me about a time for practice. A time for, we'll do like a study day on Friday. So look for that email from me. Hopefully this helps.